so Joe DiMaggio was a baseball player in the 40s and the 50s. I remember him in the 70s. Let's start this thing here. Did I start recording? Yeah, I did. I remember in the 70s he did commercials for Mr. Coffee.
Mr. Who?
When coffee was a new thing.
Coffee?
Not new, but the automatic drip coffee makers, they were brand new. That's how old I am. I was a little kid then. But. So, there's two things that managers and baseball teams really look at. And those two things they look at mainly are batting average and slugging average. And there's a big difference between the two of them. Does anybody know the difference between batting averages and slugging averages?
I don't even know the difference.
You don't know the difference? Okay, so batting average is the number of hits over the number of at-bats. Basically, that's like the clear statistic that everybody has for baseball. It's pretty simple. You hit a ball, you get fair and it doesn't get caught out, and you make it to base without getting tagged out, that's a base, right? That's a hit. Doesn't matter whether it's a single, double, triple, or a home run. That's a fair hit, right? It is a hit. Now, the number of bases you get per hit is different. How many bases do you get if you hit a single? Here's how you know. How many bases do you touch when you get a single? 1. How about a double? A triple is 3 and a home run is 4. So, the slugging average, and I would write this down even if you're new to my class because it's going to be on the test. You're going to have to take this test sooner or later, okay?
Yes, sir.
Slugging average is the number of bases earned over the number of at-bats. Now, most of you have a basic understanding of baseball. You go up to bat, the pitcher throws a pitch at you, and you either hit the ball, you strike out, you hit it into someone's glove, and you're out, okay? Or you get tagged out as you're running, right? So, this is if you make it to base. Doesn't matter which base you make it to. It's the number of bases earned over the at-bats. Slugging average gives a true test or a true statistic to the ability of the hitter, okay, to get on base. And to get on base in the scoring position also. Of course, we all know the scoring position in baseball is anything second base or above, okay? So let's look at it from this perspective. Joe DiMaggio is giving us, they give us a lot of stats here. He has a total of 2,214 hits. They give us the singles, the doubles, the triples, and the home runs. Now, I'm going to tell you something. If they give you in the test just the doubles, the triples, and the home runs and the hits, you should be able to calculate the singles, right? By elimination. If you're not given the singles and you're given the total hits, you can determine what the singles are just simply by subtracting all the other hits to find out how many singles you got. But in this case, the bases earned, we're going to look at it from this perspective. Bases earned, we can just call it bases, is 1 time the singles plus 2 times the doubles. That's number of doubles, okay? Plus 3 times the triples. And, of course, 4 times the home runs. Okay? So the bases earned is just all these numbers. You put weight on each base. Of course, second base is a little more valuable than first base. Third base is great because you only got 90 feet to home run, or to get a score run. And a home run is just, you're hitting it no matter what. You're getting a base. You're getting 4 bases. All right? So let's look at Joe. Joe had a really good year that year. He had 133 singles, or 1,333 singles, plus he had 389 doubles. We'll multiply that by 2. He had 131 triples, times 3. And then he had 361 home runs. And that's times 4. We're going to put that in brackets and we're going to divide by the at-bats because we have to take the slugging average and divide by the at-bats. The number of bases divided by at-bats to find the slugging average. It tells us how many at-bats he has, 6,821. Don't mistake the number of hits for at-bats, okay? A lot of people make that mistake. So the slugging average is this number divided by 6,821. Okay? Now we just have to do the math. Of course, when you multiply 1333 times 1, you get 1333. 389 times 2. Want to help me out? No? Maybe?
Can you move? I'm trying to see.
Can I move?
778.
Does that work for you?
No, not that time.
Would you say 778? 393? 1444, right? We divide that by 6,821. Now, I go out of my way to make sure my students understand. I put these brackets here, different from my parentheses, on purpose. I do the same thing on the quarterback ratings. Because you want to do your numerator before you divide by the denominator, because if you don't, you may get into this habit of writing this all down and then put divide by 6,821, and all you're dividing by 6,821 is this number right here, not the whole thing. So do your numerator first before you divide, so you don't make that mistake, okay? So let's go on. Slugging is, somebody want to help me out here what that addition is?
That addition?
Yeah.
Add all the top numbers and then divide the bottom.
Yeah, that's the best way to do it. And I do that on purpose because if you're going on your calculator and you're adding all these numbers up and then you divide by the number and you didn't put the parentheses in there, you're not following the order of operations of PEMDAS, are you? It's going to do PEMDAS if you forget the parentheses to make sure all the addition is done before you divide. It's only going to divide into that last number that you add.
Is the top number 2,648?
2,000 what?
648.
I'm going to take your advice. 4, 7, 15, it's 18. Yeah, well, the last number's right anyway. I know that.
It's
3,948.
3,948.
3,948 or 548? I didn't hear you, Mr. Lee.
Yeah, 900. 3,948.
I'm going to have to get a calculator out to be sure.
And then, yeah.
You're going to divide this problem to find out what the slugging average is.
And that's going to be
Should be 0.
a decimal.
Yeah.
6.65.
Okay, so I know the answer is wrong because it's 5. The answer is 578. So that addition is wrong. So that's 8, 4, 7, 15, 18. 5 and 9 is 14, and 7 is 21, 24. 6, 7, 8, 9, 16, and 3 is 19. 3948. Is that what you got? 3948?
Mm-hmm.
Yeah.
Did I do my math wrong somewhere?
Move it.
Let me get a calculator. I'm driving me crazy here.
It's a,
Should have grabbed one at the beginning. All right. So 13, 33
it's right here.
plus 389 times 2
Okay.
plus 131 times 3 plus 361 times 4. 3948 divided by 6821. 578.
Do you want us to round the last number or no?
Round it to 3 decimals. Okay, I don't know if any of you follow baseball very carefully, but most numbers in baseball, when you're talking about statistics, are round to the 3rd decimal. So out of 1,000. So this is 579 out of 1,000 at bats. He'll get. That's how many bases he get out of 1,000 at bats. He'll get 579 bases. Now, if you want to know his hits, his batting average, you would simply have to divide this 2214 by 6821. Okay? So, everybody got that slugging average down? This should interest several of the students in this class since it's football season. Quarterback ratings. Quarterback ratings were created to put a level field on how to rate a quarterback for managers and offensive coordinators. They did it in the NFL, and it applies to all different levels of quarterback sport, or sports with quarterbacks, specifically football. Okay? So in this case, we need to know what the quarterback ratings formula is. So the quarterback rating is, we start with 25. Everybody has 25 over 12. Plus, if I'm not mistaken, I'm going to double check this because it's not on the board. So I'm going to pull this up so I can get it. So here it is, 25 plus 10. 10 times the percent of completions plus 40 times percent of TD minus 50 times percent of interceptions plus 50 times yards. Okay? Now, just like in the slugging average, make sure you do the numerator before you decide you're going to touch that denominator. Don't try to divide until you've finished calculating the numerator. That's the best way I can teach you to do that. Now, here's the problem with this. One thing you don't know is, how do you calculate these variables? Well, it's kind of important to understand why some of them have the percent sign and some of them don't. If it has a percent sign, you need to give the value in this, you need to place the value in the formula that is the percent. All right, so percent completion is the number of completed passes over the number of attempts. All right? And that's in percentage. All right? So whatever that is, I would multiply that by 100 so you get it in percentage. Okay? The number of, or the percent of TDs is the number of TDs over the number of attempts. And that's also multiplied by 100 so you get the decimal equivalent, or not the decimal equivalent, you want the percentage. The last one, same thing. The last one is percentage anyways. The number of interceptions over the number of attempts multiplied by 100. And this last variable, yards, it's just yards per throw. Yards per attempt. It's not percentages. Total yards over number of attempts. And that's not multiplied by 100. Okay? So, we could go ahead and try to put this all together, but you might make mistakes. So what I suggest you do is find what these variables are, then plug them in. Okay? So, Peyton Manning had an awesome passing year in 2004. He threw 336 passes. In other words, he completed 336 out of 497 attempts. 300, let me get another pen. This thing is, I'm not having a good day with these pens. 336 out of 497, okay? And we can do that calculation later. For 4,557 yards, did I do that right? Was I doing that right? Completions out of passings, I put it in the yard section. Nobody caught me, I did it wrong. I'm trying to teach you guys how to catch me when I make mistakes. This is completions, 336 out of 497, and we're going to multiply that by 100. Okay? Total yards, 4,557 over 497 attempts. Now, we don't have to multiply that by 100. Okay? 49 touchdowns and 10 interceptions. So 49 divided by 497 times 100. And then 10 interceptions divided by 497 times 100. Now we just have to do the math. Okay? So, 336 divided by 497 times 100, 67.6, and that's percentage, okay? That's his percent of completion. 67.6 of his tosses were completed. Pretty good year. Touchdowns, 49 out of 497 attempts is 0.098 times 100 gives us 9.85 or 9.9. We'll round, okay? Percent of interceptions, 10 divided by 497 times 100 is 2.01. We'll go with 2.0. And then 4557 divided by 497, he has a 9.17 yards per attempt. That's pretty good. Per attempt, that's not per toss. Per attempt. He threw it in the air and magically it got in their hands at least for 9.17 yards. Okay? So now we're going to plug this all into the quarterback rating. Okay? So our quarterback rating is, start with 25 always, plus 10 times the percent of completions, which is 67.6, plus 40 times the TD percentage, which is 9.9, minus 50 times the interceptions percentage, 2% of his passes were intercepted, plus 50 times his total yards, which is 9.17. And then we're going to take all of this and divide it by 12. All right? I know, it seems confusing, and actually it's a lot more complicated than this. This is the, what I would call the dumbed down version. Okay? There are limits to everything for each section, and that limits makes this all different. We just divide by 12 is one of those things that we just do. So we're going to get 25 plus 676 plus 360 plus 36 is 396 minus 100 plus, I don't know what 50 times 9.17 is. 9.2 is what we need to put it at. What's 50 times 9.2? Well, that's wrong. 50 times 92. 460. Now we can do this math. 25 plus 676 plus 396 minus 100 plus 460. So 1457 divided by 12, his quarterback rating is 121.4. Now, I lived in Tennessee for 15 years. Peyton Manning played for the University of Tennessee when I was up there, and he was a god to the entire state of Tennessee. Matter of fact, I'll tell you something. When I moved down to Texas, and I'd been to Texas, I'd lived in Texas before. The only UT I'd ever heard of when I went to Tennessee was the University of Texas. But there's two different colors orange, and one's right, one's wrong. I'll tell you what, burnt orange ain't right. Watch the University of Tennessee play, you know what I'm talking about. It's a good team. Maybe not as good as A&M, but
What?
A&M just lost.
I said maybe not as good as A&M.
They're better.
Nah, I'm saying what?
Yeah, they're better.
Well, I don't know. I haven't followed college football in a long time. At one time, when Manning was at the helm over at UT, and a lot of the years after that, University of Tennessee is a great team, steeped in pride just like A&M. Come on. I don't know any other school has Rocky Top as their theme song. Come on. You get a chance to go to UT. It's a great school for football. It's a great school for anything, actually. So that's how you calculate quarterback ratings. A good quarterback rating is somewhere above 95. So you can tell he had a stellar year. One of the reasons why he had such a stellar year is because he went all year and only had 2 interceptions. So look at it. If you look, 50 times the number of interceptions, right? Percentage. That's a lot. So if you have a higher interception percentage, there you go. All right. So let's move on to the next question. Fan cost index. It's kind of a tough question. Now the fan cost index compares separate things at all venues. Okay, so it's checking the venue's prices to see what's a better value. So the Rangers play in a different stadium than the Astros. And the Spurs and the Mavericks and Rockets all play in different venues. And the Cowboys and the Texans, obviously, they play in Dallas and Houston. But the thing is, they're looking at the same things. Average ticket price, the cost of soft drinks, cost of adult beverages, cost of hot dogs, parking programs, and a cap. But the weight of each one is very important to understand. On fan cost index, you need to understand what the weight of each one is. And I don't tell you what that is. I would strongly suggest you write this down for your test. The fan cost index is 4 times the average ticket price, because it's a family of 4 going. 2 adults, 2 kids. Now, the adult ticket's going to be more than the kids' tickets, but that's why it's an average ticket cost. It's the average of those. Since you have 2 adults and 2 kids, it's the same way. You have 4 soft drinks, all right? Two adult drinks, we'll call them other, not 4. Why? Because the kids shouldn't be drinking. Plus 4 hot dogs, right? Family of 4. Okay? Plus parking for 1 parking ticket. Plus 2 programs. The adults get programs to look at the players' stats. And 2 adult-size hats, okay? Or caps. Why they get adult size? If I took my kids to a game, I'm getting them a cap. I'm not getting one. I'm going to pay whatever the cost is. Look, most of those caps are over 20 bucks. If I'm paying 20 bucks for a cap, my kid's getting it, not me. That's just the kind of dad I am. What kind of memory would they have if they went up there and dad got himself a cap, didn't give you nothing? My dad's selfish, narcissistic, right? Okay, so now that we know this, we can figure out what the fan cost index is for each team. Okay? So let's just pick one team at random. Now, even though it's basketball and baseball and football, we're comparing apples to apples now. We're looking at the best value. Now, we need to dismiss the fact that we like football over baseball or baseball over basketball. Okay? We'll just dismiss that fact altogether. We're just looking at the supreme value of what it's going to cost to take a family of 4 to this particular game. Okay? The question asks, which one is the best value? In other words, which one's the cheapest? What are you going to get the most bang for your buck? Okay? So, let's look at the first team, the Rangers. Rangers FCI for the Rangers. 4 times $16.47 for the tickets. All right, $16.47. Plus 4 times $3 for the soda pop. Plus 2 times $6.50 for the adult beverage. Plus 4 times, if I'm not mistaken, $2.75 for a hot dog. Or cheap hot dog. Cheapest hot dog out there, right? Look. Programs, we're getting 2 programs. Oh, parking, I forgot parking. Parking is $8. 1 times 8 plus 2 programs at $5 a piece. Plus cap, which is 11, 2 times $11. All right? So, fan cost index. We can do all of this. There's no division in this one. This one's easy. Multiply it all together. You don't have to worry about it. So, 4 times $16.47 plus 4 times 3, which is 12, plus 2 times 6.5, which is 13, plus 4 times 275. These new calculators. Plus 1 times 8, which is 8. Plus 2 times 5, which is 10. Plus 2 times 11, which is 22. Anybody get what I got?
Mm-hmm.
What'd you get?
The same thing you got.
Yeah? What was it?
You got the thing what you got first.
No, they don't work like that.
Bro, where'd you get the ice? Southern?
Not wood shop. Wood. Oh, wood.
141 and 88. Now I do more, but it'd take too much of my time away from you to be able to take the test. You can do this for each one of these. Find the fan cost index for every one. This Rockets one that's blank just means that they're free. The programs are free to go to the Rockets and see their player stats on that piece of paper. Question would be, if you're going to choose a team in Texas to see and wanted to spend the least money for your family of 4, which of the teams above would be the best bargain for your money using the FCI? FCI stands for Fan Cost Index. That's pretty simple. Do this to all of these. There are 7 teams. Find out which one's the cheapest. I promise you, it's probably the Rangers. Okay? All right, the other question would be, if money were no object, in other words, you were filthy rich, and you wanted to take them to the most expensive team, you do this and find out which one costs the most. And I guarantee you that that one is the Cowboys, because they're overrated.
50
Let's go
pounds.
fill it
Starting
out.
receiver. Overjacked.
I do. She's not here.
Oh, if he's something,
She is.
touchdowns.
Yes, sir. All right, bye. Marcus and Kayla, can you guys go to 1819, please? See Mr. Robinson. Please. And throw that away. All right. Y'all got this fan cost index? You got the slugging average? You got the slugging average, quarterback ratings, fan cost index. The only thing in the unit that wasn't covered on this review is final grade averages. And I'll do that real quick for you if you want me to, because I know you need it. Fan cost averages is cool, but this has got a little more practical spin to it. Final grade averages for y'all kind of important. What I need to focus on is how the test question is written. So pay attention, folks. On the final grade averages, we need to know what are we grading. So for instance, let's say that I had a class that I took my test average and I gave them 50%, okay, the grade. And then on my final exam, I gave it 25%. All right? No, let's make it 20%. There we go. And then quizzes were 15 and homework was 15%, okay? So all we gotta do is once we get these grades, we just multiply by the decimal equivalent. Okay? So let's say Coach Primo gave you 3 tests and you got a 57, a 99, and an 88. Okay? So you just have to add those together and divide by 3. That's how you find your test average. Normally I'll give 3 tests in a 6 weeks period. So 57 plus 99 plus 88 is 244 divided by 3 is 81.3. And we just multiply it. Say we got a 78 on the final. Quizzes we're carrying a 90 and homework we're carrying an 88. What's the total? Total grade is the weighted averages of each one of these. So the 81.3 times 0.5 is 40.5. And the 78 times 0.2 is 15.6. 90 times 0.15, which is 15%, is 13.5. 88 times 0.15 is 13.2. Now we just sum these together. That's how you calculate final grade averages. The test problem will probably give you 1, 2, or 3 different teachers and their grading schemes, and you're supposed to find out which one, if you're given scores for each one of these rows, gives you the best total score. Okay? So, let's move on. Next question. Past FCI. Is going to be binary to decimal and decimal to binary. This is where it starts to get simple. While it may seem really complicated at first, it's really not. What you need to remember Decimal uses a base 10. Binary uses a base 2. So in the decimal numbering system, we have 10 single-digit numbers, and we use them. For instance, the ones number, the ones position, the tens position, the hundreds position. Well, they don't have that for binary. Those systems are different. You have the ones position, you have the twos position, the fours position, the eights position, 16, 32 position, 64, and 128. We're only talking about an 8-digit binary number, which is called an octet or a byte. So we only need to know this, and what we're looking at is this. In decimal, we go ones, tens, hundreds, thousands. Well, how do we get those numbers? We're simply multiplying by the sequence of the number and the digit. So we take whatever that number is and we multiply it by 10 to the 0. Okay? So this is 10 to the 0. This is 10 to the 1. We multiply that number times 10 to the first. We multiply this number times 10 squared, which is 100. This number times 10 to the third, which is 1,000. And so on. We're doing the same thing in binary numbering. The difference is, instead of base 10, we're doing base 2. And we do it all the way up to the 7th one. And if you look carefully, you'll know that these numbers coincide. 2 to the 0, any number to the 0, according to laws of exponents, any number raised to the 0 power is 1. So it just so happens that this is the ones digit, right? This one is the twos digit. 2 to the first is 2. 4, 8. Notice we're just multiplying by 2. If we take 10 and do the same thing, 10 to the first is 1, times 10 is 10, times 10 is 100, times 10 is 1,000. We're doing the same thing here, except we're doing it by 2. 2 times 1 is 2, times 2 is 4, 8, 16, times 2 is 32, times 2 is 64, times 2 is 128. That's where I get this series of numbers at. Now, why is that important? Because I told you when we taught this lesson that the basic computers only know switches. What do I mean by switches? They have a bunch of memory cells, and those memory cells either know that they're on or they're off. They're getting electricity to them or not. And by that, they can understand, by just a series of switches, what numbers and letters are. So for instance, let's say we had this number, 111011100. Now it's a binary number, and it's called a base 2 number, a binary number. And it's an 8-digit binary number, also known as an octet. But we can easily tell when there's a 1 in that position, say the switch is on, and we add the number that is there. If it's a 0, we don't add that number. It makes it that much simpler. So for this instance, we're going to add 128. We'll add 64. We'll add 32. We won't add 16, but we'll add 8 and 4. Okay? So we just add them together. It's 236. You might remember how to quickly determine if a binary number is even or odd.
The first number.
The first number, that's right. That's the same way we find out if it's even, odd, in a decimal number, right? We look at that last number, it's divisible by 2, it's even, right? We do the same thing for a binary number. Look at the last number. If it's 0, it's even. If it's 1, it's odd, because it's the only odd number here. All the rest of them are divisible by 2. Very simple. 1 is up on the first digit. We know that it is an odd number. Okay? How about, you want me to do another one? Want me to do another binary to decimal, or you guys got it? Another one? Okay, you got it? All right, let's do decimal to binary. Now on this one, we use what's called modular mathematics, remember? We're going to divide by the binary number 2 to find out what the number is. So let's see, 208. 208 divided by 2 is what? Let me move this down a little bit. One more bell and we'll go to lunch. We know that the 8 is an even number, so it has no remainder, right? So when we divide by 2, we're going to get 104, and 0 is our remainder. We divide that by 2. It's also divisible by 2, 52. That's also divisible by 2, which is 26. One more. Now we're at 13. We divide that by 2. We have a remainder of 1. The answer is 6, because 6 times 2 is 12, plus 1 is 13. Divide that by 2. We know it's even. 3. 3 times 2 is 6. But 3 divided by 2 is just 1. 1 times 2 is 2, plus 3, plus 1 is 3. So, always divide by 1 is your last answer, so you can find it. The binary number reads this way, from bottom to top. This is your binary number. And we're going to check it. We said it was 208, right? So 1101, 0000. Obviously, it's an even number, which 208 is. But we had 128, 64, and 16. What does that give us? 128 plus 64 plus 16 is 208. So we did it right. The next two numbers are really easy. How many figured this out already? 128, this is your binary number. 1 followed by 7 zeros. 64, just as easy. Make sense? 35, however, you can figure this out really quickly once you start understanding how this works. 32 plus 2 is 34, plus 1 is 35. Okay? But doing this works every time. Every single time, okay? Now, the next few questions are more vocabulary, okay? So we need to pay attention. It all has to do with what we learned about how to switch from decimal to binary. What math process is used to convert binary to decimal? The question is written incorrectly. If we're converting from decimal to binary, no, that is the right. What math process are we using? What do we call that? What kind of mathematics was it? Do you remember?
That's not that one. Is that one?
That's binary. It's called modular mathematics, remember? Or modular math. You remember we figured out how to climb Mount Everest and how long it would take us? We figured out how long it would take us and we knew what time we'd get back, right? What is the remainder called when converting from binary, from decimal to binary? Not to decimal, from binary. The remainder stems from this word right here. The remainder is called a modulo. Okay? Who can answer this next question? You drive 30 hours and start at 4 a.m. Is the modulo the answer? Notice it doesn't ask you to do any math. Anybody notice that? So let's look at it from this perspective. What is the modulo on a problem? We just said it was a remainder, correct? So we're starting at 4 a.m. We're adding 30 hours to 4 a.m., which is 34, right? How many hours are on the clock? 12. So we want to know what time it is in AM or PM. The quotient gives us even or oddness, will tell us whether it's AM or PM, depending on when we start. Okay? So, 34 divided by 12. That's not 32, 34. 2 times 12 is 24. We got 10, remainder 10. Okay? Now, let's think about this for a second. 2 means we're in the same sequence of hours. We're in that AM area. But that means we're at 10 a.m., right? According to this. Let's check it. We start at 4 a.m. In 12 hours, in 24 hours, it's going to be 4 a.m. again, right? How many hours are left? 6, right? You had 6 hours to 4 a.m., you're at 10 a.m. So you know that that's correct. So yes, the modular is the answer. The modulo is the answer to what time we arrive. 10 a.m. Okay? All right, the next questions are very simple if you understand third grade math. All right, third grade math vocabulary. How many of you remember your third grade math vocabulary, except for the first problem, I think? In this problem, 12 divided by 5 equals 2, remainder 2. Which number is the modulo? Let me write the whole problem now. 12 divided by 5 equals 2, remainder 2. Which number is the modulo? The last problem we just did, we described a question that said, what do we call the remainder in modular mathematics? We called it a modulo. So obviously the answer to this is simple. The remainder is your modulo. Okay? Which one is the divisor? This is third grade math, folks. You learn how all these vocabulary words in third grade.
The number you're dividing it
The number you're dividing it into, or the number you're dividing with?
I said the number you're dividing by.
Yes, the number you're dividing by. He's right. The divisor is the number you're dividing by. Okay? What about the quotient? It's a lot easier than you think.
Number you're dividing with.
Nah, that's the dividend.
That's the dividend. If this is the dividend, that only leaves one left, right?
Oh, yeah.
The answer to a division problem is always the quotient. Okay? In multiplication, the two numbers multiplied are the products, or I'm sorry, the factors, and the answer is the product, right? Best part about multiplication is most of the times you don't get a remainder, right? Well, that's it for the whole thing. You guys have the rest of the class to work on the test.